The last example that I want to talk about for whether or not the octet rule is satisfied is the case where I have too many electrons. This is actually an extraordinarily important case, and it points out the flaw in simply teaching the notion that you're trying to satisfy the octet rule. Let's take a look at the periodic table a second. It is certainly true that something like carbon or nitrogen or oxygen or fluorine wants to try to satisfy the octet rule to become like neon. And it is also true that things like silicon and phosphorus and sulfur and chlorine will want to be like argon, satisfy the octet rule for that. But the big difference between the second row and the third row is that the third row is bigger. Unlike the second row, which has s orbits and p orbits, s gives me 2 electrons, p gives me 6, that makes 8 altogether, 2 from the s, 6 from the p, octet rule, sounds good. The third row has 2 electrons from the s, 6 electrons from the p, but 10, remember this is the n equals 3d, 10 electrons available into that orbit. Well, if I can put electrons into the 3d orbit, I don't necessarily have to satisfy the octet rule as I do in the second row. And in fact, that's what's happening. When things start to get too large for things like phosphorus or sulfur or silicon or chlorine, they say, all right, enough. I'm not going to try to cram it all into the second row, s and p's. It doesn't fit there. But I've got the d orbit sitting there in the third row. I'll just dump all the extra stuff there. And then this notion that only 4 bonds can be formed goes out the window. Yes, nitrogen can only form 4 bonds. Yes, oxygen can only form 4 bonds because it only can form the bonds in the second row. But phosphorus? Sulfur? I don't think so. In fact, that's when it becomes possible to expand beyond the octet, expand beyond 4 bonds, and have 5 bonds, 6 bonds, 7 bonds available. Because they're not going to go just into the s and to the p, they're going to be able to go into the d's. What does this mean to us when we're drawing this stuff? Nothing. When we get to the point where we have too many electrons to satisfy the octet rule, don't sweat it. Just put them somewhere else. Let's take PCl5. Spread it out. And by the way, this is one of those places where, once again, I get annoyed that they don't take the time to teach you how to draw 3-dimensional structures. So I've got this collection of chlorines, just like 5 of them just sort of hanging out awkwardly around the phosphorus. How many electrons do I have available? I've got, let's see, 5 from the phosphorus, 7 times 5 from the chlorine makes 35. That's 40 altogether. And now I'm going to have to try to satisfy the octet rule. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. After a while, we stop this nonsense. But I've made chlorines happy. 8, 8, 8, 8, and 8. Phosphorus has 10. 2, 4, 6, 8, 10. And I can't get away from that. I can't just have some sort of inverse rule that says, go away, leave me alone. I have to use all 40 electrons. They can't go hide somewhere. They have to participate in the bonding somehow. At that point, I realized that I cannot draw 4 bonds around phosphorus. It is too big. It is hypervalent. And because it's hypervalent, I have to draw 5 bonding structure. So you'll see people show you these awkward pictures like this because they insist on not letting you draw the 3-dimensional picture. I would say to you, let's draw the 3-dimensional picture for this. The 3-dimensional picture isn't that hard. It's a triangle in the plane, and then a couple of sticks above and below. And even though I can't draw to save my life, that looks pretty good. I put my phosphorus in the middle. I put my chlorines around the sides. And there's phosphorus pentachloride. This looks like a 5-electron rich region. They do it a little bit better than I do, but at least I did it early enough for you to be able to take advantage of it. And I've satisfied the drawing of this picture. Only the chlorines have a satisfied octet rule. The phosphorus has to put electrons into the d orbits.